Hi everyone, so I'm going to be going through C3 differentiation. In this video, I'm going through the chain rule. So, the chain rule states that dy over dx is equal to dy over du times du over dx. So you might be thinking, what does all this mean? So let me go through an example and I'll explain it using this example. So, let's say for example, we have an equation here. Y is equal to x cubed minus 24 all cubed. So, at first glance, you'd be thinking, how do I differentiate this? Because normally you just have an equation, so x cubed minus 24, and you'd have to differentiate that. But now we have this power, so it becomes a bit more difficult. But nothing's difficult in maths with practice. So, if you had just the bracket in the middle, it would be alright. You could differentiate each term and do it. So why not make life easier? Seeing this equation that we have many u's, let's see everything in the bracket. So all this stuff, x cubed minus 24, let's let u equal everything in the bracket. So x cubed minus 24. If we let x cubed minus 24 equal u, we can now differentiate this thing that we've made here, this equation. So normally if you have an equation y is equal to x something, you'd have dy over dx. Because we have u instead of dy over dx, we have du over dx. And that would equal, so we have u is equal to x cubed minus 24, so du over dx, so we differentiate this thing now. If you differentiate x cubed, you get 3x squared, and if you differentiate minus 24, you get a constant, so it's 0. So you have du over dx is equal to 3x squared. So we now have one component, du over dx. We can tick that off. Next, we let all of this stuff here inside the bracket equal u. So why not rewrite the equation being y equals u cubed? Let me just put a line there so we know. So why not just let it equal u equal y equal to u cubed? So if we have this equation, so we have y and u, so instead of dy over dx, we have dy over du. So if we differentiate this now, we have dy over du, because it's not x, it's u. That would equal, so if we differentiate this, we get 3u squared. So now we have another term, dy over du, which is here, so we can tick that off as well. Now we have both terms, we can work out dy over dx. So if we write dy over dx would equal, so our dy over du, which is here, 3u squared, and we have our du over dx, so multiply by, our du over dx is 3x squared, so we have 3x squared here. We can now rewrite, so let's simplify this first. So we have 3 times 3 is 9, so we have a 9, then we have the x squared, and the u squared. Now, we don't have u in the original equation, so why leave it here? Instead of leaving it here, let's replace this. So this is all equal to 9 x squared, and replace the u as what we had made it here. So we know u is x cubed minus 24. So we can use this minus 24 here and put it here. So we have x cubed minus 24 and make all of that squared. So our final answer for the differentiated version is 9x squared, x cubed minus 24 all squared. So the method over here was pretty straightforward, but it's kind of long-winded. You have to do quite a few steps and everything. There's another short way that I really like to do it. It's in the book, it's in the Edexcel book as well, but some people don't really like to use it. I really like to use it. It's a really good trick. So let me go through it. So it states that if y is equal to fx to the power of n. So in the previous example, we had a function x cubed minus 24 to the power of something. So we had to the power of 3. So if you have any equation, so y is equal to a function to the power of n. So any equation to the power of n, you can work out the derivative by using this formula here. So you have n, which is the original power, then you have fx, which is the function inside, n minus 1 to the power is reduced by 1, and you times by the differentiated. So this seems a bit long-winded, but trust me, it's much quicker than the other way. So let me go through it with an example, and then I'll show you a useful way to remember it. So we have this one over here. So y is equal to x cubed minus 24 all cubed. So if we have a look at this, our function is the part here, so x cubed minus 24. That's our fx inside there, and we have our power, which is n. So, if we want to work out dy dx, all we have to do is use this formula here. So, dy dx is equal to n, which is our power here, 3. So we put the 3 here. We have fx, which is our function here. So we have x cubed minus 24. You have power n minus 1. So our n's 3, so n minus 1 would be 2. And we have our differentiated. So if we differentiate x cubed minus 24, as seen previously, the differentiation of that is 3x squared. So we've now come with this equation here. If we simplify this, so we can time, because this is a power, we can't really multiply it out, but we can multiply the 3 here with the 3x squared here. So 3 times 3x squared would give us 9x squared. And then we have the bracket here, which is x cubed minus 24 all squared. As you can see, this was done in 2 steps. We got the same answer, 9x squared, x cubed minus 24 all squared. Here we got 9x squared, x cubed minus 24 all squared. Here I've done it in 2 steps. Here I've done it in various steps. So as you can see, this method is really short and it's really quick and it's pretty simple to learn as well. So one way, so if you, obviously it's not in the formula book, so one way I like to remember it is 3 simple steps. Number 1, bring down the power. That's the first thing you should do. You bring down the power. So you have an n here, you're bringing down the power into the front. So you have n, you bring it down. Step 2, reduce the power. So you have n, you bring it down, then you reduce the power here. So that's the second step. Third step, reduce the power. So we bring down the power, reduce the power, then after that you multiply by the differentiated. Multiply by the differentiated. What I'm writing here seems like pretty common sense, but trust me, whenever you see a question like this, think of these 3 steps. Bring down the power, reduce the power, multiply by the differentiated. If you remember this, you can differentiate any function to any power. The third equation or rule that they've kind of derived from the chain rule is this rule over here. So if y is equal to, so one function, which is gx, inside another function, so if you've done C3 functions, it should kind of make sense. So if you have one function inside another function, you can derive that dy over dx is equal to the differentiated function, so f, and you leave the original function inside there, then you multiply that whole thing by the differentiated of gx. So the main thing that I've done and used this for is when I'm differentiating trig functions. So I haven't really seen it that much in otherwise. So if you haven't really done trig functions, skip this part of the video, and when you've actually learned it, come back to it. So let's say we have an equation y is equal to sine 2x. So we have y is equal to sine 2x. So we have our function which is sine, and we have the another function, so in terms of this, the f is the sine and the gx is the 2x. So if we want to differentiate this, so our dy over dx would equal to, so we differentiate the f, so the differentiation of a sine is cos, so you bring a cos here, you leave the gx, so you leave the 2x here, and you multiply by the differentiated. So if we differentiate 2x, you just get 2, so we multiply the whole thing by 2. So then this leaves us with 2 cos 2x. So this is another quick way you can differentiate. The most time I've seen this is in trig functions. I haven't really seen that many examples apart from this. If you've seen any, please leave a comment below because I want to see some of them. But yeah, this is how you'd use this form to differentiate equations of functions in this type of form. So the last part, but definitely not the least part, is this rule over here. So it seems like a pretty just simple, like a fraction thing. It doesn't seem like you'd actually need to remember anything here, but this comes up all the time. Past papers and all the questions that I've done, this comes up all the time in C3 differentiation. So you really need to remember this. So it seems quite simple. So dy over dx is the same as 1 over dx dy. it just seems like 1 over a fraction. You just flip it over because you have one. So if you times, so let's say you times here the top and bottom by dy. So 1 times dy is dy. Dx divided by dy times by dy just becomes dx. So it's the same thing here. This is the same as dy over dx. You think that, oh, why would I use this? So let me go through an example. So let's say you have an equation. So x is equal to 5y squared. Let me just separate this here. So let's say you had the equation x is equal to 5y squared, and you wanted to differentiate this. So if you were to do it in the conventional way, you'd rearrange for y. So you do divide both sides by 5, you get x over 5 is equal to y squared. Then you square root both sides, so you get root x over 5 is equal to y. Then if you differentiate this, then you're going to start getting x power halves everywhere, and it's too messy. Using this thing here, normally if you differentiate, you have equation y is equal to something x, and you differentiate y with respect to x. Here, you have x is equal to something y, so instead of getting dy over dx, you're going to get dx over dy. So if you differentiate this, you're going to get dx over dy. I hope you see why I'm doing dx over dy, is because x is equal to something. So if you differentiate it here, it's with respect to y. So dx over dy is equal to, so if you differentiate 5y squared, you get 10y. So now you know dx over dy is 10y. And using the rule here, if we want to find out dy dx, we get it's 1 over dx dy. We have dx dy, so we know that dy dx is just 1 over dx dy. So instead of doing all this power business, whatever you had to do would be a long method. You just do it straight away, find dx dy, and just do 1 over dx dy is equal to dy dx. This makes it much simpler to do stuff. In the exam, if you start doing power halves, it will get confusing, you won't get anywhere, and you'd lose marks. So using this method helps a lot. Alright everyone, so this is all that there is on the chain rule. I hope that you guys understand this now, and I hope you like this video. If you did, please like, comment and subscribe. Please comment on other topics from maths, physics, and maybe other stuff like economics and computing that I can do. Please leave comments down below so I can make more videos. And also, as you might have seen in my last video, I did it on the computer. Here I've done pen and paper. Please let me know which one you guys prefer, because I find pen and paper much clearer and easier to explain. Please leave comments below on your opinions too. I hope you like this video, and see you guys next time. Bye.